Unit 3, Section 1 notes. This is transformations of quadratic functions. So these are broken up into sections by type of transformation. So let's go to the first one, A, translation. Examples: describe the transformation of the function compared to the parent function. Okay, so real quick, the parent function, if you have forgotten, for a quadratic is just y equals x squared. So there are no transformations on that, and that's it. You can tell because there's no numbers. So you just want to compare everything to that parent function. So let's look at number 1. Number 1, I have x minus 2, so that would be x minus h, right? If I'm doing letters. And plus 5 would be plus k. So now the question is what does it mean if I do minus and plus, right? Minus h and plus k. If you need to, at the bottom, we can write some notes. So if I have x minus h, that's going to be the same thing as shift right. So if you need to write all this down, you can. If you already know this stuff, great. My other one on this one was plus k. So if I had like some x squared and then afterwards plus k, a plus k just means shift up. So if you want to, we can go ahead and write these now. The opposite of these, so x plus h, would be shift left. And then of course x squared and then minus k would be shift down. So these are the only 4 translations that you can have, because those are the only directions that we have, right? Up, down, left, right. Alright, so going back up here, if I have minus 2 or minus h, that is going to be shift right 2, because now we have a number. And if you want to use units, you can, 2 units. And then the k, plus k or plus 5 is shift up 5 units. And those are the only 2. That's it. Pretty easy. Alright, number 2. Now I have x plus h and then minus k. So plus 7 minus 4. So again, plus 7, if we go back to our notes real quick, the plus h is shift left and the minus k is shift down. So left and down. So plus 7 is shift left. And then 7 units. And minus 4 is shift down 4 units. And since these are only translations, that's all you can do, right? I can't go left and right at the same time. That just doesn't happen. So I'm done with 1 and 2, and that's it for translations as far as a function. Okay, now we're going to do this on the graph. So same thing. I guess these are different numbers, but that's okay. Alright, so we have x minus h plus k, right? So when we have a graph and we have a quadratic function, this is called vertex form because it gives me h and k. So if you want to call it that, we can. I'm going to go ahead and just start it with starting point. We'll talk more about vertex on the next lesson. So our starting point is going to be h comma k, but well, no, I'll just keep it like that. But you got to follow the same rules as the translations above, right? So we have minus h, which is right, plus k is up. So on here we have right and up, okay? So that means I'm going to go right 2, up 1, Okay, so I'm going to start at the center. You always start at the origin for these. So I'm going to start at the center, right? And I'm going to go right 2, up 1, and there is my starting point, or my vertex. Okay, so I have that. Now I'm going to use what's called the quadratic pattern, which I'll write down here. So I like teaching the quadratic pattern. It's definitely faster and, in my opinion, easier than creating a table every time. A table just takes a really long time. Well, people always ask me, well, I don't even know what numbers to pick in there. So to avoid all that confusion, I just use the quadratic pattern. The quadratic pattern is simply, well, let's see. So I start from my vertex. You move left and right, or left or right, right? Because it's a quadratic, or parabola, we know it's a U shape. So we move left and right 1, then up 1. Then again from the center, or from the vertex, you move left and right 2. Again, this may not make as much sense writing it out. Then up 4. So the reason we go 1, 1, 2, 4 is because this is an x squared, right? So again, there's a lot of different ways to write or draw this. So this would be x, this would be x squared. So if x is 1, 1 squared is 1. If x is 2, 2 squared is 4. And so if it was 3, it'd be 9, 4, 16. You get the picture. Okay, so that is the quadratic pattern. So on a graph, let's see how this looks on a graph. It's actually very simple. So here's my vertex. Okay, so I'm going to go over 1, up 1. There's a point. Over 2, up 4. 1, 2, 3, 4. There's a point. And because we know it's a quadratic, which is a parabola, the shape, it's a U shape, right? So I go the other direction. I go over 1, up 1, there's a point. Over 2, up 4, there's a point. Okay? So to make my U shape graph, all I'm going to do is from the center I can go up like that, and go up like that, and there's my parabola. It's kind of like a semi-V, I don't know, it's a U shape, right? If you drew it as a U, it'd be fine, but that's how it looks. So you just go over 1, up 1, over 2, up 4. Of course, when we get into the stretch and compress, that'll change, and we have reflections that'll change too. But just the basic pattern is 1, 1, 2, 4. That's how I always think of it. Alright, the next one we have x plus h and minus k. So of course we know that plus h is to the left, minus k is down. So I'm going to go left 2, down 4. Okay, so again, you start from the center. So I'm going to go left 2, down 1, 2, 3, 4. So there's my center, my vertex, my starting point, whatever you want to call it. And now I'm going to use my quadratic pattern. So from the vertex, I go over 1, up 1. I go over 1, up 1. I go over 2, up 4. 1, 2, 3, 4. Over 2, up 4. 1, 2, 3, 4. And you could go 3, 9 if you wanted to, but as long as you have these two right here, that'll give you the basic shape of the parabola. That's all you really need for a generic shape, because we're not really looking for too specifics on things. But you could do the 3, 9 on this one because we have room. I'm not going to, because there's really no need. Again, I just draw from the center of the vertex, just go through my points like that, and there's my parabola, and that's it. So that's how you do translations on a graph with the quadratic pattern. So next page, B, we have reflections. So on reflections, let's just write some notes real quick. So there are only two reflections. We can, well, not shift, sorry, reflect over the x-axis. And we can reflect over the y-axis. So they look very similar, and these are very tricky. People get them confused all the time. So to reflect over the x-axis, I would have to have one of two things. I could have y equals negative x squared with no parentheses, or I could have y equals negative parentheses x squared, right? As long as the negative is not inside the parentheses, that is reflecting over x. Now, of course, just the opposite is true. If I had y equals parentheses negative x and then squared, that's the only variation I could have for reflecting over the y-axis. So it looks like there's three options. There's really only two, because the first two on the x-axis are technically the same. Because the negative is not directly attached to the x itself, you would actually square x or do whatever else with x squared before you do the negative, which is why it's over the x-axis. So, looking at this up here, on number 5, so the negative is outside the parentheses. So outside is reflect over x-axis. And that would be my whole answer. Because we're only doing reflections, there's only two reflections you can have. Which means this one, because the negative is inside the parentheses, I would reflect over the y-axis. And that's it. Now we can do these on a graph. So I'm going to do these on a graph, and because I'm only doing reflection, I have no translation left, right, up, down. So my vertex or my starting point is always going to be in the center if I don't have any other numbers. And because I'm doing negative on the outside, that means my u is going to go, whoa, not like that. It's going to look like this, upside down u, because that's reflecting over x. And I'm going to use the same quadratic pattern, right? I can still go over 1, and instead of going up, I'll just go down. So over 1, down 1, over 2, down 4. So from here, I can go over 1, down 1, there's a point, over 2, down 4, there's a point. And then the same thing on the other side, over 1, down 1, over 2, down 4. And then I just draw my nice U the best I can make it. And I'm good. That's my graph. That's it. Okay, now let's do the other one. This one sounds kind of dumb and pointless, but I mean, you still got to know about it because it still exists. It's still a thing. So if I'm reflecting over the y-axis, my u is actually going to look the exact same as the normal. It's going to be up. Okay. Because it's like a mirror image vertically, so it actually looks the exact same. So my origin is my vertex again, and I just use my normal quadratic pattern. So I go over 1, up 1, over 2, up 4, and then same thing on the left, over 1, up 1, over 2, up 4. And then I can draw my nice U. And that's it. So if I reflect, I can either go down, straight down, or it looks like it's normal up. No different. And that's reflections. Alright, vertical, stretch, and compress. So before we do that, let's go ahead and write the notes, if it'll let me. Okay, so I could have y equals a x squared, where absolute value of a is greater than 1. have that, where absolute value of a is greater than 1, then I have a vertical stretch. And by absolute value of a, that just means when you look at the number in front of x, or the a, you just ignore the negative. So if there's a negative there, don't count that, because remember, negative actually makes it reflect. It doesn't do anything else. So if I had like -2, I would only look at the 2, and 2 would be greater than 1, so it would be a stretch. So when you do stretch and compress, you ignore negatives completely and just look at the number. So my only other option for this is ax squared, except absolute value of a is less than 1. This would be a vertical compress. And just something about compressions, if you want to write this down, you can. To be a vertical compress, it's pretty much guaranteed, or it's a requirement. It has to be a fraction, because only fractions are in between 0 and 1. There's no whole numbers. So if you want to write that down there, must be fraction. Now, that's not saying that all fractions are compressions, because there are plenty of fractions that are greater than 1, like 3/2 is greater than 1, 7/4 is greater than, there's a bunch. So vertical compress has to be a fraction, but fractions can be stretched, okay? So don't just look at a fraction and just assume it's compression. It's not always like that. But let's look at these two examples. So my a is 2, right? That's going to be my ax squared. So again, I look at just the number. I don't have a negative anyways, but 2 is greater than 1, so this would be a vertical stretch. And that's it. Since we're only doing stretch and compress, there's only one thing to look at. Alright, I'm not sure what's up with the fraction sign on here, but 1/2 is my a, so that's my ax squared, right? And because 1/2, again, it's a fraction, but not guaranteed compress, but 1/2 is less than 1, so we have a vertical compress. And that's it. Stretch and compress. Alright, now let's look at this on a, wow, that one really messed up. Okay, so on a graph. So on a graph, my a is 2 on this one. So the only thing that really changes is my starting point is still going to be the origin, since I have no translation, no h, no k, so I'm not moving left, right, up, or down. So I started the origin, but what changes here is the quadratic pattern. So I'm not sure if you want to write this down, but quadratic pattern changes when you stretch or compress. Only because you're multiplying everything by a certain number now. So you multiply the up and down by the a. So for example, this one. So my a is 2, right? So if I were doing my quadratic pattern, let's say here's my vertex, I would go over 1, up 1, right? And then over 2, up 2, right? Now, because I have a, I'm actually going to do 1 times 2, 2 times 2. So I'm actually going over 1, up 2, over 2, up 4. So everything is doubled because I'm multiplying by 2. Hopefully that makes sense. I know that 2 looks like a Z. Sorry. Alright, so on my graph, I'm going to go over 1, but instead of up 1, I have to do up 1 times 2, because my a is 2. So I'm going to go up 2. And I go over 2, and instead of going up 2, I go up, oh, I'm sorry, that isn't 2, it's 4. Wow. Glad I caught myself here. Good looking out. So over 1 up 1, over 2 up 4, but it's 4 times 2, which is 8. Good catch. Alright, so over 2 up 8. So 1, 2, 3, 4, 5, 6, 7, 8. Way up here, right? Somewhere up there. And now I do the same thing on the left, the other side. So I go over 1 up 2. There's a point. Over 2 up 1, 2, 3, 4, 5, 6, 7, 8. That's a good guess. Alright, now I can do my real skinny tall U, right? This is a stretched U, which is why it's a vertical stretch. And there's my parabola. I'm done. So again, take the quadratic pattern times A, in this case times 2, and that's why it makes it longer or taller, which is why it's a stretch. I'm stretching it vertically. Alright, next one. So again, my A is 1/2. Not sure why the fraction line moved. So here's my A. So on this one, let's say here's my vertex, right? If I'm going to go over 1, up 1, over 2, up 4. So there's 1, 2, right? So now the up part, up and down, I multiplied those by my A. So times 1/2 times 1/2. So instead of 1, 1 times 1/2 is just 1/2. 4 times 1/2 is 2. So I do my vertex. Of course, here I have no h and k, right? So it's on the origin. And so I'm going to go over 1, up 1/2. Over 2, up half of 4, which is 2. So if I did 3, it'd be half of 9, which is 4.5. I'm not going to worry about that one though. So I go on the left the same way. So I go over 1, up 1/2, over 2, up 2, because it's half of 4. And there's my U. Notice this is a much wider U because I'm vertically compressing, or it's pressing down, so it'll be wider. And there's my stretch and compress on a graph. And that's it. Sweet. Thought we had more. So we have translations, reflections, and then stretch and compress, and that's it.